Okay, let's look at the homework 3.4, number 8. Alright, so you have a semicircle and the rectangle is inscribed in a semicircle, in the semicircle. Right, so first we have to know the equation for the semicircle. Right, remember that the equation of the circle with radius r is x squared plus y squared is equal to r squared. Right, then by solving for y, we can get, let's see, we can subtract negative minus x squared, subtract x squared, then you have a y squared is equal to r squared minus x squared. By taking the square root of both sides, we'll get the y is equal to plus or minus square root of r squared minus x squared, right? Then the positive one is the top semicircle and the negative one is the bottom semicircle. In this case, we're looking at the top one, so the equation for that would be y is equal to positive square root of r squared minus x squared, right? So any point on the semicircle can be written as, so x comma y is actually x comma square root of r squared minus x squared. Right? So since we want to maximize the area, so let's write the expression for the area. So area is a rectangle, so base times height. Base in this case, since this is x, so this is negative x, so base is actually 2x, right? So it's 2x times height. Height right here is just simply the y coordinate of the point, so it's square root of r squared minus x squared. Right, so it's a square root of r squared minus x squared. Right, then we can take the derivative of the area function a prime is equal to, right, so product rule, so this is the first guy and this is the second guy. Derivative of the first is 2 and second is square root of r squared minus x squared, right, plus first guy 2x and derivative of that, remember that the square root is 1/2 power, so put the 1/2 power in front, keep the same quantity r squared minus x squared and subtract 1 from the power, so 1/2 minus 1 would be negative 1/2, then multiply by negative 2x. Right, then you can see that there's 2 and 2 cancel out and we'll have this. So if you simplify that, you get the 2 square root of r squared minus x squared and minus, right, there's going to be x here and there's a negative 2x there, so it's going to be 4x squared over square root of r squared minus x squared, right? Then we're going to take a common denominator. We'll get the common denominator would be square root of r squared minus x squared, right? Right, so if you multiply this guy by square root of r squared plus x squared, you get the 2 times r squared minus x squared, so 2r squared minus 2x squared. And then we still have minus 4, actually, sorry, this was actually 2, because this 2 was canceled out, so it was just only 2, sorry. So it's 2. So it's minus 2x squared. All right. So we can simply clean it up a little bit. Then you have 2 is in common, so 2 is outside. And you have r squared. Right? These two guys give you negative 4x squared. So you know, factoring out 2, so it's negative 2x squared over square root of r squared minus x squared. All right. By setting that equal to 0, maybe I'll do it. Setting that equal to 0, we can get, right? So all we have to do is set the numerator equal to 0, so we don't have to worry about 2. So r squared minus 2x squared must be 0, right? Then by adding 2x squared, we can get the r squared is equal to 2x squared. So we can divide through by 2. So divide through by 2 to get the r squared over 2 is equal to x squared. Right? Then we can just take the square root of both sides to get the x equals, right, square root of r squared over 2, and of course plus or minus, right, is equal to plus or minus r over, because square root of x squared is r, and then you have a square root of 2, right? Since we only worry about the x value, it would be, there's a negative version and a positive version. We only have to worry about the positive one, so we take the positive one as the critical number, right? So x only goes from here all the way to r. So maybe I should write that. So x is between 0 and r, right? Then, so that's a critical number, and let's make sure that we get the maximum area there. So it's between, x is between 0 and r, right? Then you have r over square root of 2, right? It's somewhere around there. All right, so let's look at the sign of the a prime. Right. So if you look at the derivative function right here, so here, right? If you plug in something smaller than you know, r over square root of 2, for example, you can try r over 2 or something like that. So if you plug in r over 2 here, so you're going to have r over 2 squared, so r squared over 4 times 2 is r squared over 2. So r squared minus r squared over 2 is going to be positive, so you're going to get a positive sign here, right? And if you try something you know, bigger than r over square root of 2, so maybe like r, then you can see that if you put r here, then you have r squared minus 2r squared, so it's going to be negative. So if you plug in a prime r, it's going to be negative, right? So it's going to be always negative here. So this is the a function is increasing before r over square root of 2, after that decreasing. So we know that the maximum happens at this critical number, right? So therefore, r over square root of 2 is the x value to maximize the area, inscribed area of the inscribed rectangle, right? Y can be found by using the y is the square root of, y is equal to square root of r squared minus x squared. X squared, we just found r over 2, so it's going to be r squared over 2, which is going to be square root of, right? So this is 2r squared over 2, so 2r minus r would be r squared over 2, which actually gives you r over square root of 2, right? So actually y is r over square root of 2 as well. All right, that's it. I hope that this was clear.